Section 3.3, Measures of Position. This includes finding a standard score, percentiles, deciles, and quartiles. They are used to locate the relative position of a data value in the data set. For example, 80th percentile. That does not mean 80%. It means 80% of the values fall below and 20% of the values fall above it. Likewise, if you had 50th percentile, that is the median, meaning that 50% of the data is above that value and 50% of the data is below that value. A z-score, or standard score for a value, is obtained by subtracting the mean from the value and dividing the result by the standard deviation. As you can see, you've got the z-score for a sample, and this one is for your population. If the standard score is 0, then the data value is the same as the mean. We are going to assume that the data were obtained from samples. Now, this z-score represents the number of standard deviations a value is above or below the mean. If a z-score is positive, the score is above the mean. If a z-score is 0, the score is the same as the mean. And if the z-score is negative, the score is below the mean. So those values are giving you a position and where this is in relationship to the data. A student scored 65 on a calculus test that had a mean of 50 and a standard deviation of 10. She scored 30 on a history test with a mean of 25 and a standard deviation of 5. Compare her relative positions on the two tests. So using our formula for z-score, you take your data value minus the mean, divide by the standard deviation. So for calculus, it was 1.5. For the history one, it was 1. So she has a higher relative position in her calculus class because of the numbers being compared. Percentiles separate the data into 100 equal groups. A percentile rank for a datum represents the percentage of data values below that datum. So percentiles are the positions used in educational and health-related fields to indicate a position of the individual in a group. So if any of you have ever gone to the doctor's office and they've talked about your percentile in weight or height, that is a measure of trying to compare you to other people on that particular values. Here is a graph that has been made. Percentile graphs use cumulative relative frequency distributions, except for on the y-axis, they do not use the decimal. They're going to change it to a percentage value. And in terms of how to read this percentile graph, let's say, for example, you wanted to know if someone was falling in the 130. What percentile that would be. So go on the x-axis, go up to the graph, then look to the vertical axis, and you can see that is at 70th percentile. Now, if you want to go the opposite way, let's say you wanted to know, all right, what's the value going to be if I'm at the 40th percentile? So start with the 40th, go over to the graph, look straight down, and that's going to give you the number for the 40th percentile. Looking at this example on page 153, A teacher gives a 20-point test to 10 students. Find the percentile rank of a score of 12. Put the numbers in order. And then we want the number 12, so we're going to count how many numbers are below 12. That happens to be 6. So 6 plus 5/10, and then divide by how many total values are in that data set, which is 10, and then multiply by 100. This gives you 65%. So a student whose score was 12 did better than 65% of the class. Another example, a teacher gives that same 20-point test to 10 students. We want to find the value that corresponds to the 25th percentile. Again, the numbers need to be in ascending order. We use the formula down here to figure out what that percent is. So we take n, and n is the total number of values, and p is the percentile. So I want 10 students and the 25th percentile, so 10 times 25, and divide that by 100. That will give you 2.5. Since this C value is not a whole number, we are going to round up. Once you get the C value, 3, you need to count left 3 spots to get your value. So it's 3, I go 1, 2, 3. So 5 corresponds to the 25th percentile. If C is a whole number, you're going to use the halfway value between C and C plus 1. See example 3-33 on page 155 for something to look at. Deciles separate the data set into 10 equal groups. Quartiles separate the data set into 4 equal groups. And then the interquartile range is found by taking quartile 3 minus quartile 1. It is considered the range of the middle 50% of the data values. Here is a procedural table on how to find quartiles. Arrange the data in order from lowest to highest. Find the median of the data values. This is the value for quartile 2. Find the median of the data values that fall between quartile 2. This is the value for quartile 1. Find the median of the data values that fall above quartile 2. This is the value for quartile 3. Go to page 156 for an example of how to calculate quartiles. Putting the data in order, we're just splitting it up into each section. So quartile 2 is that median. Quartile 3 is the median of the lower half. Quartile 3 is the median of the upper half, where quartile 1 is the median of the lower half. You can add up the numbers and divide by 2. Outliers can affect how the data is resulted. So it's really important to know if your data has outliers in it. In order to figure that out, you would need to go through a process. But one thing to consider is that outliers can strongly affect the mean and standard deviation. That is why they are called non-resistant statistics. The median and interquartile range are not as affected by the outliers. They are called the resistant statistics. When your distribution is skewed, the median and the interquartile range should be used rather than the mean and the standard deviation. So how do you identify those outliers? This procedure is found on page 158 in your book. You're first going to arrange the data in order from lowest to highest and find quartile 1 and 3. identify the interquartile range by subtracting those two values, multiply the interquartile range by 1 5/10, subtract the value obtained in step 3 from quartile 1, and then add that value to quartile 3. Once you've got those two numbers, that's going to identify, okay, if you've got a number that's less than that, then that may be a good qualifying for an outlier, or if there's one larger than that, that may also identify an outlier. Go to example 3.3 on page 158 to see how this is done. Pause the video to make sure you have enough time to do so. Why outliers occur. There are a couple of different reasons why outliers may occur in our data. For example, there might be a measurement or observational error. Maybe there is a recording error. Possibly the subject was not defined in the population, or it's a legitimate value that occurred by chance. This concludes section 3.3. Please now go to Connect Math and work through some examples on that website. Thank you.